Evaluating the reliability of the Givebutter API requires looking at its core infrastructure, endpoint availability, rate-limiting frameworks, and webhook delivery consistency. For developers and nonprofit administrators building custom integrations, automated workflows, or CRM synchronization tools, understanding how the platform performs under regular operational loads is essential before committing code to production environments. The foundation of the Givebutter API relies on a modern REST architecture protected by bearer token authentication over HTTPS. Access is open, free, and self-serve for platform administrators without requiring custom enterprise tier approvals, which lowers the barrier to entry significantly. When testing endpoint stability, developers generally encounter predictable response codes. Successful calls return standard JSON payloads, while validation failures consistently trigger structured 422 errors containing explicit message arrays and error fields. Authentication errors are similarly clear, returning 401 codes for missing or invalid tokens and 403 codes for authorization mismatches. Rate limiting plays a massive role in perceived platform reliability. Givebutter enforces a cap of 500 requests per minute. For the fundraising and nonprofit software sector, this threshold is generous and comfortably handles typical synchronization tasks, routine data polling, and bulk lookups. If an integration exceeds this limit, the server responds with a 422 adjacent standard 429 too many requests status code accompanied by a retry after header. One minor drawback noted by developers tracking infrastructure patterns is the absence of live budget tracking response headers, meaning applications cannot dynamically inspect remaining rate limit quotas mid-run without tracking call counts locally. Webhook reliability dictates how dependably external databases update in real time when actions occur on a campaign page. Givebutter supports critical event subscriptions covering successful transactions, refund creations, new contacts, ticket generation, campaign modifications, and recurring plan updates. A major advantage for introspection is the inclusion of queryable delivery logs via the API, allowing systems to look up historical delivery statuses, payloads, and response codes if a sync error occurs. However, architectural gaps do exist that affect end-to-end reliability if not properly accounted for in application logic. Certain properties lack update-specific webhook triggers. For instance, changes to existing contacts or modifications to ongoing transactions do not fire independent update events, forcing developers to rely on polling mechanisms or secondary triggers to keep external records fresh. Furthermore, recurring donation plans remain strictly read-only through the public interface. While applications can observe and ingest state changes like plan failures or pauses, they cannot programmatically instantiate or alter subscription structures via write commands. Documentation consistency has historically presented minor hurdles. Canonical paths hosted on the primary domain sometimes diverge slightly from mirror documentation portals regarding schema parameters or total available webhook definitions, requiring developers to cross-reference live implementation tests. Additionally, early webhook configurations created prior to mid-2026 required manual regeneration to ensure proper signing secret attachments, a configuration quirk resolved in newer account setups. Ultimately, the Givebutter API proves stable, predictable, and robust for standard donation tracking, alert triggers, and lightweight automation workflows. While missing granular update webhooks and right-side recurring billing controls mean developers must design workaround logic for complex enterprise architectures, the core data pipelines operate dependably within stated rate parameters.